Today, I'm going to show you how to adjust the initial timing on your Model A by a precise number of degrees. So for example, you can set it to 7 degrees after top dead center or 12 degrees before top dead center. Now, why would you want to do this? Well, hey, it's none of my business why you'd want to do it. It's your car, you do what you want. But usually people do this because they have some system for adjusting the timing that maxes out at a certain degree value of total timing, and they want to adjust that up or down. So their actual goal is to dial in a total advance of, 25 degrees or 45 degrees or whatever. Before we dive into this, I want to make sure everyone's on the same page with terminology. So let's take a look at the Model A Spark Advance quadrant. Now, when your spark lever is at the top, right, so that's usually called fully retarded, that's your initial timing. Whatever degrees of spark advance you've got when the lever is here, that is the least possible advance that you can have. That's what initial timing means, the point where no advance is being applied to the distributor. And when your spark lever is at the bottom, which is also called fully advanced, that's your total timing. Whatever degrees of spark advance you've got when the lever is here, that's the most possible advance you can have. So initial timing, total timing, right? So keep that in your head as we go through the video. Now, on a car that's configured according to the factory settings, your initial timing here should be 0, meaning that the spark plug fires when the piston is exactly at top dead center. The quadrant permits the lever to sweep through 40 degrees of crankshaft advance. So that means by moving the lever from here to here, you've advanced the spark timing by 40 degrees. So if you're starting at 0, then your total timing is, right, 40 degrees. Now, as I said, sometimes folks want to adjust this total timing. Maybe they want to set things up so that when you crank the lever all the way down, you're only at 30 degrees advance or 33 degrees or, whatever. Or maybe they've got a distributor that uses an automatic centrifugal advance, like this period add-on. This is the Phillips automatic centrifugal timing device. Or this is the Model B distributor. These devices have a fixed number of degrees of advance that they add on. And maybe that's too much or too little for your engine. So for example, the Phillips device adds about 29 or 30 degrees of advance. Maybe that's too much. The Model B centrifugal advance adds about 15 degrees of advance. Maybe you think that's too little. Whatever the case, if you want to increase or decrease your total timing, the simplest way to do it is to adjust your initial timing by the same amount. So in effect, you're taking the advance curve and shifting it up or down, but not changing the shape. So how do you do that? There's two basic approaches that you can take if you want to set your initial timing to a point other than top dead center. And you can rotate the crankshaft by the amount of degrees that you want, and then set the timing as if you were at top dead center. So I'll call that, let's call that crank adjustment. Or you can keep the crank centered, but rotate the distributor cam by the amount of degrees you want. So let's call that cam adjustment. In this video, I'll show you both methods. Crank adjustment is faster and easier than cam adjustment, but it really works best if you know exactly the setting you want and the shift is pretty large, like over 10 degrees. Cam adjustment takes longer and you have to have a little bit more equipment, but it can be used to make very small adjustments and get exactly the timing you want. Now, there's one method I recommend against. I love Nurex. They've done a huge amount for the hobby. I love their products, except this one. This is the Nurex Precision Timing Kit. This just does not work in my experience. The first problem is the wrench that comes with the kit. The tang on this wrench, the thing that catches the slot in the cam, it's just not well machined. There's a lot of slop between the wrench and the cam, and so it wiggles. And you just can't do precision cam locating with this wrench. And the second problem is this disc that they give you. When you first look at it, it kind of looks like these ticks are for individual degrees, right? Like 2 degrees, 4 degrees, etc. But actually each of these ticks is 10 crankshaft degrees. It says it in small print right here. So the smallest mark that you can go by, right, if this is 0, then the next mark here is 5 degrees. And then the next one is 10, 15, 20, etc. And so if you want to do like 7 degrees, like where are you going to aim? And it's just a weird design. Like why would you want 80 degrees of advance, right? Like all the action is going to happen more or less in this like tiny section of the arc. So it's just not well designed. It doesn't give you enough precision, and it's really like it kind of flops around. So I don't recommend it. So here's the supplies that you're going to need for crank adjustment. You'll need a way to check for your points opening, right? So that could be a test light or an ohm meter. You'll need a way to rotate your crankshaft in both directions. So that could be a crank wrench, or you could just put the car in gear. You'll need a way to visually inspect the number 1 piston when we're looking for top dead center. You'll need a device called a degree scale or a degree indicator, or you can just use a fixed reference mark, like a fixed piece of wire near the pulley. And you're going to need some white paint and a marker of, some color, black or whatever, and you'll need some digital calipers and a little bit of tape. So what is a degree indicator? It's a piece of steel that bolts to the timing cover, and it gives you a reference measurement for the rotation of the crankshaft. So trying to make sure you can see right there. So this is one, it's got markings from 0 to 30. This is a really nice one. This one is stainless steel, laser engraving. It's made by Dave Delmouy of Model A, only in Morgan Hill, California. Now for cam adjustment, you're going to need everything that I listed for crank adjustment, plus you're going to need a digital timing light that lets you set the advance. This one's the Actron CP7529. You're going to need the new wrench timing wrench. I'm sure most of you have seen this. And you're going to need an extra spark plug connector. Yeah, see, now you're going to have to watch the whole rest of the video just to find out how a spark plug connector figures into this. So the first thing you have to do for either the crank method or the cam method is to find top dead center as precisely as possible. Now, the timing pin, that'll get you 95% of the way there, but when you're dealing in single degrees of crankshaft rotation, you got to be 100% certain. So to get that extra 5%, we need to make it as easy as possible for the engine to rotate. So you can see here I've removed all the spark plugs, and that'll let air escape from the cylinders, so the compression stroke won't actually be compressing anything, and the engine will be much easier to turn. So the next step is you need to use a crank wrench or another tool. So I actually have the correct size socket on here, and I've got a breaker bar on here. And you're going to turn the crankshaft until the timing pin drops in. And then when it drops in, you'll be very, very, very close to top dead center. You may even be right on it, but we really want to get a second opinion, get some kind of verification. And what we're going to do now that we're right in the immediate vicinity of top dead center, is we're actually going to observe the number 1 piston and mark when it reaches the top of its travel. Now, if you have the stock cylinder head, which I don't, but if you do, you should be able to actually just look through the spark plug hole with a flashlight. Just use your eye, and you should be able to see the piston. But if you have a high compression head, the combustion chamber is a lot more compact. It's a lot shorter, and so you might need to use an endoscope or another method to visually inspect the piston. Okay, I'm going to show you one way to view piston travel on a high compression head. So this here is a Wi-Fi endoscope. It connects to your phone, or in this case an old iPad, and it transmits the camera image to your phone. These cost about $50 on Amazon, and it's got a little light on the end. It's very handy. So what we're gonna do, let's see if I can get this to work properly. I'm gonna thread this into the combustion chamber. So keep in mind the piston, right? It's like right over here. So here is the biggest problem with locating top dead center visually. People think that the piston's path is going to kind of look like this, like it's going to come up to the top briefly, and then it's at the top for just a moment, and then it drops away. But on the Model A engine, because it is a long stroke engine with offset pistons, it doesn't work like that. It works more like this. The piston kind of comes up, and then floats at the top for a few degrees and then drops back down. It's really flat up here, very hard to tell when you've reached the top. And so this is kind of important, because if you're observing the piston and you see it stop here, when it appears to stop rising and you mark top dead center there, you're actually going to be off by a couple of degrees, because top dead center is right here. So what I recommend is that you try to bracket top dead center. So here's what I mean. So you're looking at the front of the engine, you got your degree indicator here, here's its 0 mark. And then here's this is my terrible rendition of a pulley, and here's your fan belt, right? And so, here's the crank, either the ratchet or the bolt or whatever you've got there, and you put a wrench on this, and you are rotating it through top dead center, and you are observing the piston at the same time. And what you should do is you're gonna mark the crank pulley with a marker, not with paint, multiple times. So you're first gonna mark it when it stops rising, right? So you'll put like a mark here. And then you'll mark it again. You keep rotating it through, and you mark it when it looks like it starts falling. And you go a little bit past, and then you rotate it back the other way. So again, now you're like, okay, here's when it stops rising, and now here's where it looks like it starts falling, right? And then that's what you're going to end up with, usually, is a pair of marks on either side of the actual top dead center. So then once you have these marks, you can measure and find the center of those marks, and then that is your actual top dead center point on the pulley, which you can then mark with paint. Okay, so I've got it. What you're looking at right here, this is the edge of the cylinder, and then here's the valves, and then the piston is inside this hole right here. And so what I'm going to do is I'm going to crank this up. If you are doing this and you ever get momentarily sort of confused about which way's forward and which way's backward on the engine, just remember you can look at the fan. If you're turning the fan in a direction that would push air this way, then you're turning forward. So we're gonna raise this, so we're moving the piston. I just hope you can see here. Okay, yeah, see, there's the edge of the piston coming up. And you can see kind of right about here, I'm moving it, but it's like, see, I'm moving this back and forth, but the piston's not really moving. This is where we're kind of at that float. So right about there, that's where it looks like it stops, right? So that's where you would make your first mark on the pulley, where you're bracketing it. I'm gonna keep going as I continue to go forward. Yep, that's where it's starting to look like it's going down again. And then as I come back, see, it looks like it's coming up. And then it sort of stops and holds there even as I keep moving. So that's what you would do to bracket your to bracket top dead center, and then to make those marks on the pulley. Now the degree indicator that I've got mounted on this car, this is actually by Nurex. So you can see it's mounting right here on the front motor mount instead of on the timing cover, and it's got kind of a sticker here instead of stainless steel engraving. But if you look at the way that I've got my pulley set up, you can see I don't only have a white dot on the pulley, but I also have a yellow dot on the degree scale. And the reason that that's there is because I did the thing that I just warned you not to do. I marked ATDC on the pulley when the piston got to the top. But of course it floats there for a few degrees. So when I went back a few years later, as an older and wiser man, I checked it again and I found that I was actually about 2 degrees off. What I did was I left the mark on the pulley and I just put this mark here on the degree scale. So instead of 0 being here, it's here. So on my engine, when these dots line up right there, that's top dead center. So now you've got top dead center marked on your pulley and you've got your degree scale or your pointer set up. And at this point, I'm going to describe the crank adjustment method, and then I will describe the cam adjustment method. Now, if you already know that you want to do the cam adjustment method, you can just skip ahead. So let's say you've decided that you want to use the crank adjustment method, and what you're shooting for is 19 degrees advance. And that's a common target because some people have a Model B engine or a distributor, but they've got the Model A timing cover. The Model B timing cover moves the timing pin so that it drops in when you are at 19 degrees before top dead center, but the A timing cover drops at 0 degrees. So if you want to use the B motor settings, but you got the A timing cover, you might want to set to 19 degrees in another way. And so the first thing that you've got to do, if you're going to do that, is you need to get the radius, or sorry, the diameter of your crankshaft pulley. I know this is kind of a tight space, but you got to get in there. You might need to take the fan belt off. You got to get in there with some calipers and measure the diameter of this pulley. Now on mine, this is 133 millimeters. So then you got to do some math. If the crankshaft pulley is 133 millimeters in diameter, we can apply the formula, the diameter times pi times the angle that we're looking for over 360 is going to be the length of the arc on the pulley. So that determines how long a little strip of tape we're going to have to make. So 133 millimeters is the diameter, and then pi, and then the angle that we want is 19 degrees, all right, divided by 360 degrees. And what you get there is 22.05 millimeters. So now what you can do is just cut a piece of masking tape. Doesn't need to be that wide. And then, so I'm going to try to dial in 22.05 millimeters on my digital calipers. 1/100 of a millimeter is kind of hard to do on these, so I got to 22.04, and that seemed good enough. And now we're going to make our mark. Okay. So that is 19 degrees. So now we can take this tape and we're going to take it over to the pulley. Now remember, you have kind of a choice here. You can choose to mark the tape either on your degree indicator if you have one, or on the pulley itself. And you just need to kind of keep in mind that if you are putting it on the degree indicator, you need to come toward you if you're doing advance, right? So you can see marked here A. So it's going to go from top dead center toward you is where you're doing the offset. But if you're doing it on the pulley, then you would mark it the other way, so away from you if you're doing advance. So you just have to determine which way works best for you. All right, so I've put the tape onto the degree indicator with that top line right at top dead center. So that's where that white dot is lined up already because we found top dead center. And then the lower line is 19 degrees advanced, right? So we measured 22.05 millimeters, or as close as we could anyway. And so I've got my breaker bar here, and just gonna move that dot right on down. Line it up as close as I can. All right, so there you are. So this now is 19 degrees advanced. And so the next thing that you have to do is set the timing in the distributor as if you were, just setting it normally. So go do that. All right, well, I know most of you guys don't actually need me to show you how to do timing, but just in the interest of completeness, we're gonna cover it. So you've got your distributor, you've made sure that this is in the fully retarded position, and you've got an ohm meter. So you've got one lead is wired to the arm on the upper plate, which is basically the ground. And then you've got another one which is wired to the points. And you just have to make sure this is only touching the lead coming in from the lower plate. So right now, you can see, hopefully, the points are open. And consequently, I've got open circuit on my multimeter. And all you're gonna do is you got your new wrench, you follow the directions, give it a couple cycles clockwise, and now we are in basically very close to the right position. And we're just going to very gently turn this until the points close. Okay. There we go. So they've just closed. And what should happen now, as we can keep an eye on the multimeter and the crank, is as I advance this just a tiny bit, yep, just a teeny bit, they opened. So that should be good. All right, so we covered the crank adjustment method of precision timing, right? So basically we measured off how many degrees we needed. We made marks on the tape and marked that off, and then adjusted it so that the top dead center dot on the pulley lined up with the mark that we wanted for the number of degrees of advance we wanted. And then we set the timing like we normally would. And that's pretty much it for the crank adjustment method. You just, put the spark plugs back in, put the engine back together, and you're good to go. I personally, I just don't trust that method very much, or I think it gives you sort of a false sense of precision. I think if you actually go and check your results with a timing light, you'll find that you're not quite where you thought you would be, just because there's there's this sort of amount of wiggle in the when you're adjusting the pulley, and then you're sometimes like not quite right. You've got this like little bit of rotational play in the cam sometimes. And so I like to, and also sometimes if you're not going for 19 degrees, right, maybe you're only going for 2 degrees or 3. And that's going to be really hard to do because you're making such a small adjustment. So the next approach that I'm going to talk about is, I'm calling it the cam adjustment method. Now, you remember I said earlier that if you divide the crankshaft pulley into 360 degrees, each of those is roughly 1 millimeter wide on the circumference of the pulley. Well, if you have a distributor cam and you take a distributor cam wrench, right, like this new wrench, and you rotate it around the cam, that makes a circle as well. And this is actually sort of what the new Rex precision timing disc was trying to get at. They wanted you to, you put the disc over the studs right here, and they wanted you to rotate the wrench around to a particular mark on the disc. But again, problem is, the disc is too small and the markings are too far apart, and the wrench that they gave you kind of sucks. But if you could get a bigger circle with little tick marks that are closer together, then you could do it. Because remember I said also, like, all the action happens just in this tiny little arc on the circle. So you don't actually need to build the entire circle. You just need a tiny slice of it. And then you can use the new wrench to rotate the cam to an exact spot on that circle using the indicator that's already here. And then that gives you the exact amount of advance or retard that you need. So the way you do it, briefly, is you take a spark plug connector, and you're going to end up scribing sort of degree arc markings on the connector. And then you're going to basically pop the connector onto the a stud on the distributor body. And then what you're going to do is you line up, you go around like this, like it tells you, and then you're going to line up the new wrench with a particular mark, which represents the spot on our kind of imaginary degree wheel that you want. So now, why am I using the new wrench in this method? Well, unlike the other wrench, this one's really good. It's sturdy, it's got minimal slop with the cam, and it's already designed to use the existing distributor body to locate the timing with high precision. So before we get started, we need to do a little more math. Remember that for the crank adjustment method, we had to find the diameter of the crankshaft pulley and use that to figure out how many millimeters we needed to adjust. But for the cam method, we're actually looking to find the circumference of sort of that imaginary degree wheel. And what we're going to do is we're going to measure the distance on the distributor from the middle of the number 4 stud, which is the one that the new wrench is supposed to line up with, to the center of the cam. And actually what I've done here, the way I do this is I take a little tack and I put a dot on it, and I just put that into the middle of the cam screw, just to give me something a little bit easier to aim at. So, you're gonna get your calipers, and on mine, I believe this comes to done this before, and it comes to about 101 millimeters. So yeah, 101, that is right in the middle of the stud. Yeah. Okay, so if that distance is 101 millimeters, then that is the radius of a circle whose circumference is, right, 2 pi r, right? So 2 pi times 101. And there are 360 degrees on that circumference. But, wait, we want to find crankshaft degrees. The crankshaft rotates twice for each one rotation of the distributor cam, so there are 720 crankshaft degrees on that circumference. So your formula here is 2 pi times 101 divided by 720. 720 degrees. And so you do that, and what you should get is that every one crankshaft degree is 0.88139 millimeters on our little imaginary circle going around the distributor cam. So that's the distance along the arc of that circle that equals 1 crankshaft degree. And so now what we need to do is to make this tiny portion of the degree wheel using this as our increments. By the way, if your distributor body radius comes out to something other than 101 millimeters, just take that number and it's the easy thing to do. So you multiply your radius times 0.00873. And that will give you the length of 1 degree of arc for your purposes. I'm gonna use 0.88 millimeters as the 1 degree arc for this video. Now to make your the little piece of the degree wheel that you need to make for this, you take a spark plug connector and straighten it out, and you're gonna crimp the fork part slightly. Just make it kind of so it kind of goes together a little more so that it grips the stud. So in other words, you're gonna take your distributor body, you can be on the car or on a bench, doesn't matter, and you're gonna make so that this slides on just like that, all the way on, and grips it firmly, and it should be perpendicular to the stud, to the body, just like this. And then what you're gonna do is you can take a razor and you're gonna score a line right where the stud is, right here. You're gonna score a line right on there, just like that. This one I've already scored some lines on so you can kind of see. So you're gonna make a mark for the edge of the stud, just to mark where that is, and then you're gonna take this off. Now you need to make a jig to hold the connector steady, so you're gonna need a piece of wood and a nail and a clamp, and I'll show you how this goes. So here's the jig that I made to hold this connector steady. You can see I've hammered a nail in here, and this nail is going to stand in for the stud. So this is a finishing nail. It's exactly the right size. So this stands in for the distributor stud, and then I've got a clamp which is going to hold the connector. So then I'm just going to slide the connector onto here, exactly like I'd slide it onto a stud, and then I'm going to clamp it down. All right, and this is going to make sure it doesn't move. Like that. Okay. Now you're going to take some calipers and the razor, and you're going to make a series of marks for your degree wheel. This is going to be your increments. Now I recognize that 0.88 millimeters is difficult to mark, so feel free to make whatever adaptations you need, like maybe only mark every 2 degrees, or if you know exactly the amount of advance or retard that you want, you can aim for that number and just mark a few lines around that. One thing to remember, if you're looking to retard the spark, the connector is going to be facing away from you and the wrench will pass over the stud. If you're advancing the spark, then the connector will be facing toward you and the wrench is going to stop short of the stud. The other thing to remember is don't try to measure 0.88 millimeters from one line to the next, to the next, to the next. You're going to always measure from the nail. So you do, 1 degree from the nail and mark that, and then 2 degrees from the nail, mark that, and then 3. That's much more accurate. If you are trying to measure against each little scratch on the brass, you're going to introduce a ton of error, and that's in addition to all the error you've already got. So for crank adjustment, I showed you an example timing goal of 19 degrees advance. For cam adjustment, I'll show you an example goal of 7 degrees retard. So this degree connector I actually made a couple of years ago, and can't really tell where you'll be able to see, but you can see the marks I made here, I think. And I don't remember what increments I used here, but I know 1 degree is 0.88 millimeters, so I worked out a table of how many millimeters you need to mark off for each degree of crankshaft timing. Now, if you want to pause the video and copy this down, you can do that. You can generate your own. The math is fairly straightforward. So for 7 degrees, right, I'm looking for an arc length of 6.17 millimeters. So I'm going to set that on my calipers. 6.17 millimeters. So now I'm ready to make my mark. And the way that you measure this is going to depend on whether you're doing advance or retard after top dead center or before. So if you are doing after top dead center, remember that you're going to have the connector facing away from you, and the new wrench is going to come up, and your 0 point is right here at the edge that's close to you. So if you want to go 7 degrees beyond that 0 point, then you would take your calipers and you put them up against the stud, which is going to represent 0, right? And then you're going 6.17 beyond that. And then you're going to take your razor and draw a line right here, right? But if you were doing 7 degrees advance, then the connector would be pointing toward you, right? So the wrench would come up and stop before you got to the stud. So then you would, I guess I'll have to turn this back around, but if you just sort of imagine it with me, you'd want to use the other side of the calipers, put it against here on this side, and then draw your line that way, right? So the way you draw the line, it depends on what you're doing. And if you want to make, when I made this one a couple of years ago, I just wanted to make a general purpose one. So I just drew a bunch of, I made a bunch of lines. And then only later when I picked my use case would I figure out which line I was going for. I really just sort of drew lines. I think I drew them like 1 millimeter or 1.5 millimeters apart. The first thing to make sure you do is to set your crankshaft to top dead center. And then you're going to need to remove the distributor cap and rotor, and you're going to need to remove your plug connectors. Make sure that your upper plate is fully retarded. All right, pull on that, make sure that's all the way against the distributor body, and you want to make sure your cam is loose, so I've loosened this screw. So now I'm going to take my new wrench and I'm going to follow the directions on the wrench which say to go around clockwise twice. And now, when I'm getting close to the number 4 stud, I'm going to start to tighten this down. So, important to mention here, so I've got the connector pointing away from me, and that's because I am setting 7 degrees of spark retard. If I were setting spark advance, I'd want to have this thing reversed and I'd want it to be pointing toward me. So you can see there's my hash marks on the connector, and I have picked a line I'm going to go for. And it's, you can see it's this line right here, right there. So what that means is I have to pass over the stud and hit that line, or line up with that line with the wrench, and then tighten down on the cam. Right there. So once you're satisfied with how you've got this lined up and your cam and everything, then it's time to put everything back together and start the car and check to see how accurate you are. I want to add a caveat here. There are many potential sources of error when you're doing this, right? It's just starting from, when you set it to top dead center, did you set it exactly right? There's a little bit of play between the crankshaft and the camshaft. There's a little bit of end play in the cam shaft that affects the worm gear that's driving the distributor. There's a little bit of play in the distributor shaft. There's a little bit of flex in the wrench, right? So look, I mean, this thing moves, but the cam is not moving, right? Got a little bit of flex. The distributor body it's not quite firm. There's a little bit of play there. So what that means is that there's a lot of error that can build up, and you might aim for 7 degrees and get something else. But what's the flip side of that is that error is all going to move in the same direction every time. In other words, you're likely to, if you have 2 degrees of error in one direction one time, you're likely to have roughly 2 degrees of error in that direction every time. So it's fairly easy to compensate. But my point is just that there's more to this than just measuring a certain amount on that connector and then, that magically being the amount of advance that you get. You have to account for the error in the system as well. All right, I've got everything back together, and I've also hooked up my timing light, which is right there. Now I've covered this in other videos, but I just want to show you. I've got my power supply here, which is running 12 volts to the light. And I've got my induction clamp on the plug wire, and I've run the clamp wire up over the hood support rod and way out here and around because you need to keep it well away from the coil and the plugs and anything that's not insulated, and you need to be sure it doesn't touch the manifold or you'll leave melted rubber on it. So what we're going to do now is start the car and check the initial timing and the total timing to see how we did. Remember, we were aiming for 7 degrees retard, so that'll show up as, I think, -7. Anyway, 7 degrees retard, initial timing. I've got the New Rex automatic advance, so that builds in about 29 to 30 degrees advance for total timing, so subtract 7, so we're looking for 23 to 20, or I guess 22 to 23 degrees total timing. So we'll see what we get. Well, when I recorded that, I completely forgot that you can't actually check negative timing degrees with a timing light, with a digital timing light. Because every timing light, this timing light and every one I've ever seen, starts at 0 and goes up. So like you can't go down below 0. And that's true for every timing light out there. So I wasn't able to precisely measure the initial timing. So if you are setting your initial timing, as in our example, for after top dead center, you can't get a precise number on it with the timing light. You can estimate it using the degree indicator if you have the Nurex indicator, which shows degrees retarded. So you can get an idea from that. But if you want to be precise, which is like what this whole video is about, what you've got to do instead is look at your total timing and work backwards. So if you are setting for after top dead center initial timing, then I'm assuming that either 1, you've got a distributor with built-in advance, or 2, you want the spark control lever to hit a certain advance number at the bottom of its travel. So what you've got to do is just measure that with the timing light instead, right? So I knew my distributor with built-in advance would max out around 1850. If you look at this graph, 1850 is right there. That's real close to the top of the curve. So I checked that timing. Okay, we're at 1850 RPM. I've got 25 degrees of advance. It looks like that is basically where the dot is at. So it looks like we ended up with 25. In this case, the original advance on this distributor, which I checked in a previous video, you can see where I got this curve from. So this one was at 1850. Now it was supposed to be this original number, I think 29.5, and the new number I got was 25. And actually, I went back later off camera and I checked it at 2000, and it went up to 25.7, and this one was roughly 30, I think. So what we're seeing here is that these are differing by roughly 4.5 degrees. So what that means is that my initial timing way back here, that means this initial timing is minus 4.5 degrees, roughly. So that is how you kind of reverse calculate the initial timing from the total timing. So my initial timing was 4.5 degrees, not 7, which is what I was aiming for. So I wound up 2.5 degrees off. So in this case, I would need to repeat the procedure, and instead of aiming for 7, I would aim for 9.5, right? I would add 2.5 because that was the error. So I would add 2.5 and 9.5 degrees. If you look at this table, it's going to be between these two. So that would be roughly 8.3 millimeters of arc. So the next time I would aim for that line. I'd measure, you do that on the calipers, measure on your spark plug connector, draw a new line if you have to, and then measure to hit that. So again, you'd probably only need to do this 2 or 3 times before you're able to hit the exact number of degrees you're looking for. So that's it. That's how to set a precise arbitrary initial timing on your Model A. So we talked about 2 different methods, right? The crank method and the cam method. And we went through the math for how to figure out the correct offset to hit a particular degree. And we talked about how to verify your timing with a timing light. All right. Well, thanks for watching. Put your questions in the comments section, and I will see you next time.